Okay, calculus students, I'm going to finish up 4-6 on my own time, sending it to you along with a copy of the in-class lesson so you can finish up your notes. I can't afford to get behind, so I guess that's how I'm going to have to start doing some things, is do maybe half live and half not live. So even though I am alive, this presentation, by the time you receive it, will be not live. A little bit of humor there. Most classes got to example 4, which talked about the dynamite that blew a heavy rock straight up in the air. And it had initial velocity of 160 feet per second. And they gave us the equation of the position of this rock. And if you recall, the rock went up and it went down. And another picture, that was just a picture of the position of it. You know, if you looked how it went straight up and straight back down. But if you were to graph the path in a nice upside down parabola, which is what all projectile do, we had that picture here. Okay. And so the equation of this picture was the S function. And so we already covered that, but I'm just reviewing it to catch you up to speed. Was 160, which was that initial velocity. He calls it the launching velocity, time, minus the 16t squared. And we already talked about where the 16 came from and why is there negative. And we also talked about that normally your position function might look like this. At squared plus bt plus c, meaning b is my initial velocity, a is my acceleration due to gravity, c is my initial height that you're throwing something. Like we on a 50th floor, I threw a rock out. You're on the moon and we threw a rock off the moon, whatever. Now, back to this. I covered, I think for 2A, I didn't finish A as well as I thought I did, because the question does say, how high will the rock go? And I think what we figured out when somebody corrected my math, I plugged in a 64 here instead of a 32 anyway. What happened is we did eventually agree to 5 seconds of time, which matches the picture here too, 5, okay? And I ran away with that, and I started doing part B with you in 2A, and I didn't finish the problem. The problem said, how high will it go? So if you look at the rest of the work I put down here for A, S of t was 160t minus 16t squared. S of 5, because I have to figure out what's the position after 5 seconds. And that was 160 times 5 minus 16 times 5 squared, which is 25. 800 minus 400. So we get S of 5 was 400 feet. And that was in 5 seconds. Okay, that was the maximum height. Okay. Now I can move on to B. And I don't think for either class, I don't know if I finished it for either class. What are the velocity and the speed of the rock when it is 256 feet above the ground, the way up and on the way down? Well, that is because if you looked at that picture, 256 feet is roughly, I don't know, that's like 100 to 400 is 300. So 250, I don't know, we'll call it right here. Let me put a black line here. We'll put it, oh, that's not black. Right here. If I cut across to the position, there is the position when it was going up. There's the position as it's going down, going up, and we'll call this 256, okay? So he wants to know, at that second, what's the speed of this rock? And the speed would be the slope of the tangent line right there. And so it's positive. Why is it positive? Because it's going up. Velocity would be positive. Coming down on the other end, negative slope, because I said the wrong word anyway. It's not speed. Speed's always positive. The velocity was positive. The velocity is now negative. Okay. So where did I start working on this? Right here. So I need to start with the velocity. So we already calculated the derivative s prime of t somewhere up here. S prime of t, yes, we wrote right here. So I brought it down. And s prime of some number, that's what I was going to put here, is equal to the velocity at some number. And I don't know the number because I can't set the velocity equal to anything. It's not like the other problem where I set it to 0. What I had to do is I had to go to the original function where s of t, I want it to be 256. So s of t is this original function, 160t minus 16t squared, has to be equal to the height of 256. So what I'm taking is the position function, finding out how long, finding out what t has to be to get to 256. So I ended up moving I moved everything over to the right, created this nice, beautiful quadratic. I got lucky. I divided everything by a 16. And if I'm really lucky, truthfully, if it doesn't work out pretty, I would graph it. I would graph this quadratic and find out where the roots are. I don't know where they would be, but I would just find it with my calculator. But I think it's going to factor. Let's see, factors. My method of factoring is not typical. It is the factors. Well, there's a 1 here, so it's not that hard. It's either going to be an 8 times a 2 or a 4 times a 4 or a 16 times a 1, whichever combination adds up to a negative 10. And so if they're both negative, then 2 negative numbers could add up to negative 10 and 2 negatives could add up to a positive. So I'm just going to go with 8 and 2, meaning this is a t and this is a t. Okay? It's factored. Beautiful job, if I say so myself. Set each equal to 0. I get t is 8 seconds. I get t equals to 2 seconds. So my picture over here is not correct because I have negative time, which could have happened. But since this parabola does go up and come back down in positive time, then it makes more sense that the picture would have looked more like that. Okay? So this one is 2 and this one is 8. So I can go up here and answer my question. Well, no, I can't answer the question. I literally need to now find out what s prime of 2 is, which is v of 2. And then I need to find out what s prime of 8 is, which is v of 8, because the first one is smaller. So this was when it was going up. And this is the larger time, so that must mean it was now coming down. So the velocity at 2, I need my velocity equation. If you recall, there it is. So this one's going to be s prime of 2, which is v of 2. I'm hitting that in the head hard so you understand this connection, is equal to 160 minus 32 times 2. And guys, I'm not guaranteeing you anything will be correct in this because no one's there to help me out. And I really love you guys who speak up. 160, this old man always gets carried away. Minus 64, I think that answer is going to be 96 feet. And then that was going up, so it was 96 feet up. I go back to my picture up here, my beautiful picture. I'm thinking 96 feet. That's not feet. That's 96. That's velocity. 96 feet per second. And it is positive, thank goodness. And so that was going up, like I said. Now I'll do s prime of 8. So that's going to be the same formula. 160 minus 32 times 8. Now, this is where I need your help because I don't want to do the hard thinking. 160 minus 8 times 2 is 16. Carry the 1, 24, 25. 256. There you go. 160 minus 256. I wish I could do it in my head. Let's see. Negative 96. Oh, wait a minute. Per second. They're the same. The speed, which he's asking for. Oh, I love how when a plan works together. The speed is the same for both. Absolute value of 96 is 96 feet per second. Absolute value of a negative 96 is 96 feet per second. That is kind of cool to know that symmetry, as it goes up, that the slope here is the opposite value of the... Oh, it makes sense now. Hello. Okay, I love it when a plan goes together. Okay, that was velocity and speed. B is done. C, what is the acceleration of the rock at any time during the flight after the blast? Okay. He's asking me, I believe, just for the generic equation of acceleration. So C will be the acceleration, which is technically the second derivative of position, which is technically the first derivative of the velocity. Pick it, whichever what you want to do. Since I'm staring at my velocity equation right here, I'm going to use that. So I'm going to take v prime of t. Remember, v of t was, let me remind you what it was. It is 160 minus 32t. 160 minus 32t. Now, I wrote it down for me, not for you, because you already had it on your paper. And okay, so v prime of t, that goes to 0, negative 32. And this is acceleration, remember? This is acceleration, so it's 32 feet, negative 32 feet per second squared. Why is it negative? Acceleration due to gravity. The direction of acceleration is downwards because it's falling. So I feel pretty confident now with A, B, and C. D. When does the rock hit the ground? Well, okay, what goes up? I'm going to take a guess. The picture is 10. That's when it hits the ground. I would hope I wouldn't have to do a whole lot of calculus, but we can. Or not necessarily do calculus, we can do at least algebra. Let me use the position function. That position was, right, 160t minus 16t squared. Okay, here goes D. Position was 160t minus 16t squared. If I set the position equals to 0, that's when it has to be at the ground level. This is a quadratic, but it only has two terms with t in it. So you are allowed to factor out any common terms. So I'm going to factor out a t. I'll factor out a 16t. And that gives me a 10. Yeah, 10 minus a t equals 0. 16t is 0. Are you surprised that in 0 seconds it hit the ground? No, it didn't hit the ground. That's when it was shot off. So that's not the answer he wants, I don't think. He wants when it hits the ground after it hit the ground again. Yeah, you see that? He doesn't want that. That's too silly. All right, so let's do the other one. 10 minus t equals to 0. 10 equals to t. 10 seconds. Are you surprised? That's what I said in the picture, right? I did say that. Now, I'm done with the problem, but I need to share some stuff with you. Let me erase, and this is why I'm glad I'm doing this at home, because in class, I just don't have time. And so I'm going to make you guys study this on your own here. Um, he gave us this velocity picture for a reason. Remember, this was S equals 160 t minus 16t squared. And then this is my velocity. Well, look at that, guys. I had the velocity equation somewhere. If I can find it. What letter was asking for velocity? It was in B, right? We had it somewhere. Velocity, the original velocity. I don't see it. The equation of S prime. Oh, it's right here. 160 minus 32t. So, oh, there it is. 160 minus 32t. Why did I not see that a minute ago? So check it out. This is really cool to compare the two graphs graphed in the same plane. At zero, when the rock exploded up in the air, the velocity was 160. Positive velocity because the rock is going up, up, up real fast. As time goes by, it's slowing down. It's still going up, but it starts out going fast, 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 and it slows down because why? Gravity is pulling it. And then, so gravity is slowing it down, and once it peaks out right here, the velocity turned to zero. You see the graph, velocity is zero. And you can tell it was going up because the graph of the derivative is positive all the way from 0 to 5. Positive velocity. And at 5, the derivative function goes underneath the x-axis. And what it did after it stopped and became 0, it starts going down. And it was fast at first. Gravity's pulling it so hard, pulling it hard, and it's still going faster, 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 till it hits the ground. And that's the end of my commentary for this number 4, which is an excellent problem. You can feel free to look at all the gobbledygook solutions that are in the book. I'm having faith that I got them right, but I didn't have Daniela here helping me. I didn't have who else can I pick on? I didn't have who else who's helped a lot. Fourth period. Oh, I can't think of names. So I have a lot of good people. 2 pages. All right, I'm gonna do one problem of economics. There's 2 in the book, but I'm gonna do one. Economists have a specialized vocabulary for rates of change and derivatives. That's why I'm only going to do one, because I'm not an economist. We'll call these marginals. Why are they marginals? Because when you do a ledger and you have columns and rows, these numbers at the bottom are totals and monies that I'm making, and the totals are on the side. If you're in statistics or have had statistics, you've had marginals, okay? You had marginal values. They're the totals. In a manufacturing operation, the cost of production cost is a function of X, C of X, okay? The number of units produced, it's how much it costs to produce a certain number. The marginal cost of production is the cost of change of cost. It's the rate of change. It's a derivative. With respect to the level of production. In other words, you have the function for C of X. C prime of X is your marginal cost of production. Okay, nice. Suppose that C of X represents dollars needed to produce a certain number tons of steel in 1 week. So there is a certain cost to produce a certain number of tons. Let's say you always produce 25 tons of steel, whatever you're doing, and so that's going to have a C of X. That's going to have a cost for that 25 tons of steel, let's say. It costs more to produce X plus H tons per week. Well, of course, if you're making more than the 25, it's going to cost more to get there. And the cost difference is divided by H. And that means you get an average cost of producing each additional ton. That's a key word right here, additional ton. So your average rate of change, it's the average cost, will be the same thing as your f of x plus h minus f of x all over h. Again, it's average. Why is it average? Because there's no limit as h goes to 0. Not yet. Okay? So it's the average. And the limit, there you go, the limit of this ratio as h goes to 0 is the marginal cost of producing more steel per week when the current weekly production was X. So I always make 25, but what if I make 26? That extra X is going to have to be considered with this derivative of this average cost. Okay, so I do the limit as h goes to 0 of this. That's my marginal cost. So what do we have here? We have the marginal cost is the derivative of C. There it is. That's the derivative of C. Sometimes our marginal cost is loosely defined as producing one additional item. Okay. With that being said, we have C and we have C prime. Here's the picture. Here's the picture of C of X. And here's the X. So the tangent line is the slope, which stands for your marginal cost. The other picture in your book, the marginal cost is approximately the extra cost of the change of cost of producing one more unit, which is what I was saying a minute ago. Here's your problem. Suppose that the cost function is x cubed minus 6x squared plus 15x. And that is dollars. And it's dollars to produce X radiators. Okay, we're doing radiators. So to do X number of radiators when we're doing 8 to 30 radiators are produced. Okay, so there's my limit. 8 to 30 is the number that I could use in there, and I can use that formula. R of t, which is x cubed minus 3x squared plus 12x, that's called a revenue. That's revenue. That's the money I make on selling those radiators that are in the range of 8 to 30, given the dollar revenue from selling the X number of radiators. Your shop currently produces 10 radiators. So that's my magic number. My shop currently makes 10. So there's my function for 10. There's my function for revenue for 10. About how much extra will it cost to produce one more radiator a day? Because this was 10 radiators a day. Now I want to make one more a day, because that will add up to, if I work 5 days a week, 5 more radiators. And what is your estimated increase in revenue and increase in profit for selling the 11? All right. So let's start with, obviously, if I'm doing one more radiator, if I'm adding one radiator a day, I have to use C prime of X, which is not a hard derivative, 3x squared minus 6x, that's cubed, I'm sorry. Three x squared minus 12, not 6, 6x plus 15. Okay, make sure I do that right. C prime at 10, which is my amount that I normally make, would be 3 times 100 minus 12 times 10 plus 15. That's 300 minus 120 plus 15. 300 minus 120 is 180 plus $185. Okay, so there is my marginal cost by producing 11 instead of the 10. Let's talk about the revenue. How much money am I going to bring in? R of X is right here. But since I'm adding one extra per day, I got to find the marginal revenue. So R prime of X, hopefully I do the derivative correctly because I messed up right here almost. 3x squared minus 6x plus 12. But I need R prime of 10. So that is 3 times 100 minus 60 plus 12. 300 minus 60 plus 12. That's 240 plus 12. That's $252. Okay. It's costing 185, but it's good. I'm bringing in 252. This is per day of making that one extra part. Now I need to find out my estimated increase in revenue. I did that. And increase in profit. My increase in profit. How much more am I really making? Because remember, this was a cost. And so profit function should be how much money am I bringing in minus how much did it cost? And now remember, I'm dealing with profit when I'm supposed to be making 10. This is going to be the extra profit of making one part more per day. P of 10 is equal to my profit was 240 minus my cost 185. Don't blow it now. 240 minus 185 is 40 plus 15, $55, I think. And if I'm wrong, email me. What do I hear? Ding. Email. Someone's emailing me already. What did I do wrong? I can't read my handwriting. Can't offer you extra credit because we're not in. Jeez. 195. Sorry. 300 minus 120, and I know you already knew it, was 180. No, 180. There's not a 5, it's 15. 180 plus 15, 995. Okay, so back down here. So my revenue, my profit at 10 should have been 252 minus 195. I'm afraid to do the math because, let's see, 200 table is $57. Will you buy that one instead? $57 a day extra profit by just making one more radiator. And next page in the notes, okay, if you want to study the solution, they do it a lot better than me. In addition to your math lab homework, you're going to have a couple problems from the textbook. And it's an exercises 3.4. It's in your book, but here's the problem. You got number 5 and 6 needs you to do the A, the B, and the C. Okay? Show your own work on your own paper. Then you got number 7, which is its own problem. They give you a function, A, B, and C. You're doing acceleration, speed, total distance traveled. That's displacement. You got 8, A, B, and C. Now, FYI, all odd numbers are answered in the back of your book. Find them, check your own work on the odds. Submit your paper on its learning. And there's already a repository for that homework assignment. And I'm going to call it quits. So, time to go watch Town Hall. I'm not going to tell you which Town Hall I'm watching, though.